All right, well, welcome everybody to Solar Noon Tuesday. And I'm Jay Warmke with solarpvtraining.com. And if you're new to this forum, what we do is we have a number of folks online. It's a sort of a Zoom session that's going on live. But what I'll do is I'll recap the latest in solar news for the last week or so. And then we'll also highlight some of the events that are coming up, webinars, conferences, things like that coming up. And then we go into a deep dive on a topic that at least I've found of interest in the world of solar. This week, we're going to be discussing Enphase and some of the changes in their product lines, some of the issues around three-phase installation. So we'll touch on that. And then, of course, take whatever feedback from the folks who are online here live. So let's go ahead and jump into the news. So this is the news for the week of, January 12th. And there are 13 states now that have requirements to move to 100% carbon-free or renewable electricity by the year 2050 at the latest, and two other states that have set down requirements or goals, but not necessarily laws that are binding. Vermont is the latest state to require carbon-free energy, with a bill that became law last year when Democrats took control of the legislature and they overrode the veto of the Republican governor in that state. Additional states that are moving in this direction are New Jersey, which appears to be the next state poised to mandate 100% renewable. New Jersey Governor Phil Murphy issued an executive order in 2023 calling for the state to get 100% of its electricity carbon-free by 2035. But an executive order can be undone by a future governor and doesn't have the durability or substance of a law. Murphy's term as governor ends this year, and he cannot run for re-election. Renewables now make up the majority of net public electricity generating in Germany, according to a new report by Fraunhofer Institute of Solar Energy Systems. Now, as reported, the renewables account for about 62.7%, around 63% of all electricity generated in Germany in 2024. Wind energy made up most of this, comprising 33% of energy generation. Onshore energy declined a little bit, but offshore energy grew during 2024. While wind provides the greatest amount, it's followed by coal, which still generates 23%, then solar at 14.7%, natural gas at 11.7%, biomass at 8.9%, and hydro at 5%. Now, the German federal government has set a target for carbon neutrality by 2045, as well as goals to end coal-fired power generation and meet 80% of the gross electric consumption with renewable energy by 2030. Now, Germany's rate of around 63% compares to about 56% in the UK. And in the US, we're only at about 24% coming from renewables. Now, President Joe Biden announced an executive action Monday that protects more than 625 million acres of U.S. coastline areas from future offshore oil drilling. The ban on oil and gas leasing and drilling extends to most of the U.S. coastal waters. It includes the entire East Coast in the Atlantic, the Gulf of Mexico, the Pacific Ocean off of Washington, Oregon, and California, as well as some parts of the Bering Sea up near Alaska. Now, President-elect Donald Trump has vowed that he would rescind this ban upon taking office, according to the Washington Post. However, according to the New York Times, that's not so easy. That Biden had invoked the 1953 Outer Continental Shelf Lands Act, which apparently gives presidents quite a broad authority to withdraw federal waters from oil and gas development. To reverse the ban, Trump would actually have to overturn that law and have Congress do that. Now, the immediate impact of Biden's ban is minimal, pretty much symbolic. It covers areas where there's very little oil and gas development. Also, many of these have already been banned, so it's kind of doing it a second time, according to the New York Times. Now, consistent with his vision of energy policy, President-elect Donald Trump last week stated that there would be no new windmills built in America after he takes office. Now, again, that's a promise that's going to be hard to keep because basically, Trump has very little influence over what gets built on private property. So he can control federal lands and he can control the waters offshore that are controlled by the federal government. It does appear that he's likely going to advise the Bureau of Ocean Energy Management against issuing any new offshore leases. But those leases that have already been awarded, apparently the president has little or no power to rescind those. The solar installations continue to grow year over year, and commercial solar saw a significant rise in 2024. According to the Solar Market Insight report by CEA, commercial solar grew about 44% in 2024 compared to with the same time in 2023, a year earlier. Residential solar increased 39%, and community solar increased about 12% year on year. Utility scale, there was a slight downturn in the third quarter over the second quarter, a decline of about 16%. But the third quarter is pretty notorious for being the low end of installations throughout the year. And in fact, the third quarter of 2024 saw a 44% increase over the third quarter of 2023. In fact, the third quarter last year was the best third quarter of installations in history in the US. Last year, solar accounted for about 64% of all new electric generating capacity added to the grid. And while 2024 was a good year for solar, it was the industry seems to be braced for a downturn in 2025. The two leading manufacturers of residential solar rooftop inverter systems have announced layoffs to their workforce. Solar Edge Technologies, the provider of DC optimized inverter systems, completed its fourth round of layoffs just recently, removing or eliminating about 400 jobs, according to Reuters. The Israeli-based company conducted 3 rounds of layoffs in 2023, eliminating 1,800 jobs over the last 2 years. Solar Edge is really facing 2 major problems, which is leading to these layoffs. The first is that high interest rates in the United States has made the prospect of installing solar on residential properties less attractive. So there's been a decline from that perspective. And then also when Russia invaded Ukraine, the industry throughout Europe basically stockpiled large amounts of solar systems in anticipation of an increased demand with the cutoff of natural gas coming from Russia. Now, there has been an increase, but not as much as was anticipated. So there's a glut of product in the market there in Europe, which has affected these manufacturers. In November, Enphase, which is the largest inverter manufacturer for residential in the US, announced it's laying off 17% of its workforce globally to streamline its operations in the face of the same events, the same conditions, high interest rates, the Ukraine war. At least that's what's being cited. The company ended its manufacturing operations in Mexico, but it's retaining or continuing to do manufacturing now in the United States to meet the IRA provision for domestic content. Now, these moves by both of these companies, plus some other companies like SMA, are in anticipation that interest rates are going to remain high. And in fact, projections show that the residential market here in the United States for rooftop solar is expected to decline. The growth rate is going to decline by 19% this year, according to their projections. Take that for what it's worth. And if 2024 was a good year for solar, it was a spectacular year for battery storage. The ability to store large amounts of power to the grid or connected to the grid was essentially non-existent a decade ago. And by the end of last year, we were at about 24 gigawatt hours of capacity, which is up 71% from 2023. So 2024 was probably a watershed year, looking back as when batteries became a thing on the grid. However, the integration of battery storage on the grid has not been adopted evenly across the nation. As of November, 86% of large scale battery storage was in just 4 states. Leading the charge was California with 11 gigawatt hours operating. Texas was next with 6 gigawatt hours. Arizona saw nearly 2, and Nevada, which was fourth, had about 1.1 gigawatt hours operational. That's the news for solar for this week. And does anybody have anything they'd like to add to this mix here? Anything that crossed your desk or questions you may have before we get into the next stage? I know, Bill, you had said you had a question about solar panel availability. Let's see. Bill may have wandered off. We'll let him catch up to us here.
No, I'm.
Oh, there you go.
Um, I just had it muted. Um, we've been looking for a new solar panel because our supply of Longi panels has been interrupted. We were buying them for about $83 a panel at the end of last year, and that apparently all the prices are at least for us are going up. They the last time I checked, they were 127, and maybe it's in anticipation of the new tariffs and what will that will do to prices. But I wanted to find out from you, especially Jay. You were in. I know that Longi has been building a factory in a joint partnership with a company called Illuminate USA, and I think Illuminate owns maybe 51% of the factory, and then Longi owns the other portion. And I just wanted to find out and I've written to them to ask them if they had distributors that had them available, and they didn't respond. We're small change.
Yeah.
So anyway, I wanted to find out what you had found, what you know about this factory that's has completed, apparently started producing panels in the last quarter of 2024.
Yeah, I mean, I haven't been keeping up on it. I know that the factory was located near Columbus, Ohio, and supposed to be one of the larger manufacturers in the country as far as facilities. But I hadn't even heard that it was up and operational. So you're probably more on top of it than I am. Is anybody on the call? Has anyone heard anything from this? The factory was coming online in response to the IRA's domestic content requirement, where you get an extra 10%. So I think we're going to see a bunch of these popping up, but I just haven't heard specifics on that. Give somebody a second if they have a feedback. I hate to push that off, Bill. Maybe I can do some research and
No,
see if we see what the situation is. I did hear something about, it's not so easy as saying we took the cells and we're assembling them in the US. The IRA had qualifications about how much of the content had to be from domestically manufactured ingots, from domestically mined silicon, because like what China did, where when we said we were not going to import panels from China, they simply moved their assembly to Taiwan or not Taiwan, but Thailand and Cambodia and Malaysia and Vietnam. That the IRA anticipated that and didn't want to see that happen, where we were just an assembly shop.
well, we
I did see where they were canceling some of those silicon manufacturing projects. So I'm not sure if that's all falling apart.
we just have very little of our own domestic source for cells or silicon.
Yeah.
I mean, it's just we're almost totally dependent on imports.
Yeah. And almost 100% the world is dependent on China for these things.
Yeah.
Uh,
Well,
yeah, it's going to be interesting. I mean, I've long held the feeling that China has decided years ago to target the silicon panel manufacturing industry and to dominate it, and they've used unfair trade practices. Of course, they have. Um, it's resulted in low cost panels because they're being subsidized by the government of China. I personally feel it's a mistake for the US to try and compete with them because I feel like silicon is an aging and perhaps even the last generation technology. If I wanted to build an industry around solar, I would look towards perovskite and some of the new emerging technologies and say, listen, if China wants to dominate rotary telephones, that's fine. Let them dominate. We're going to dominate the next generation because we're not going to catch up to China on this. By the time silicon becomes an old technology, maybe then we'll be in second place. It feels like a fool's errand to me. I'd rather us focus on perovskite.
I just checked on the web, by the way, and they said they started shipping panels out last year.
Yeah. So
Illuminate.
Illuminate did in from Columbus.
Yeah.
Yeah.
Just outside Columbus, yes.
Yeah. And Bill, you're doing this with an organization there. You're in Kansas, is that right?
Yes.
Okay. And could you explain? I know your video is off. If that's easy for you to kick that on, could you explain to the group what that project is?
We've we've based our whole model around one that started in it was called Perry, Plymouth Area Energy Initiative in New Hampshire, where they started using solar thermal. Actually, they were using evacuated tube solar heating systems. And we just based ours on their model where we would buy in bulk and help you and just, it was basically a vegetable buyers group, where instead of vegetables, we'd buy solar hardware and divide the cost and help each other put them up. So we'd organize. We're not we're not certified installers and we're not electricians. So we've had some leniency in terms of the local uh, code and zoning people saying it would be fine for us to install the arrays because we're just plugging them together.
Mhm.
And we hire an electrician to go ahead and do the home run back to the breaker panel and install our utility requires a generation meter. So they required a meter can and the disconnects and all of that.
Okay.
So we buy the hardware in bulk and then split the cost between those buying it. And
And
we're
it's a bit like a solar barn raising type thing where everybody helps each other with their own installs.
It has been, and it's been fun, and in a dozen years we've never had anybody injured or hurt or fall off the roof. And of course, Enphase is quite safe. The height element is the most perplexing because there's no electrical risk until the last breaker is turned on.
Yeah.
All the inverters will stay disconnected until they get the utility frequency. At this point, we seem to be getting a lot of interest from people who have very large houses
Uh-huh.
and 12 kW systems that they want to put in, and we're trying to redirect that back down to habitat. And there's a group over in Topeka right now it's a Christian group that's putting 4 houses in, and they're 4 kW systems, and so we're trying to redirect more to that type of building instead of the giant, the McMansion types of houses.
Hmm. Yeah, it sounds like it's a bit like a project I'm involved with here in Ohio where we're going to be installing 75. We're calling it like polar solar. It's just
Uh-huh.
small Enphase systems with 6 panels on either a single pole or 4 poles. And it's going to be totally, ground mounted outside the home. So we don't have to climb on the roofs, and it's just going to be a very simple plug and play kind of system.
I
Um,
would like to hear more about that and more of the details about your work on that because I think it's a really good model that would fit a lot of existing houses. especially, as habitat gets into house renovate, remodeling and weatherization. That's
Yeah.
the kind of system that would work really well in this environment.
Right. And we're trying to anticipate some of the issues, like it's being designed so that it will work load side connected to a 100 amp service with a 100 amp panel. So everything has to be below essentially 3.6 kW. Um,
Excellent.
so that anticipates that from the 120% rule. But we're also looking, because the new code says you've got to have a disconnect at the meter now, an
Uh-huh.
emergency utility disconnect, essentially a sub panel that's located at your electric meter. So if we stick that box onto their meter, we never have to go inside because we can connect straight into that box that's outside. So you're coming from the pole to the Enphase combiner box to the AC disconnect to then that emergency disconnect at the meter. So that's what. Yeah, we'll do a show on that once it's up and going and share the diagram, because if it's a standardized system, we can do a 1 line and a 3 line drawing and just throw it out there. Let people have it, for their permitting and stuff.
Well,
So
Jay, it avoids a lot of the problems that you have with, older houses and lower income houses having deferred maintenance on the roof, for
yeah,
example.
yeah.
You don't have to worry about putting systems on roofs that are where the shingles are at the end of their life.
Hmm.
So there's some big advantages to that, and combined with mini split heat pumps, it'll provide a huge amount of the household's energy needs without without being bigger than that. I mean, many of the mini splits will operate on a couple of panels.
Yep. Yep. Well, it sounds like you and I are going to change the whole world here of solar.
Little bit by little
A
bit.
little bit, yeah, as long as we last. So, all right. Well, I'm going to jump on here. Thanks, Bill, for that update. We're
Sure.
going to jump into the events of the week here. I've got there's I can see that I forgot to make my notes, so I'll have to raise that up so I can look at it. Yeah, there's a session here coming up on solar Soluma batteries, which is being put on by Renvu. That's on January 15th, tomorrow, at 1 p.m. Eastern time. All these times are going to be Eastern time. So feel free to look these things up. Wood Mackenzie is putting one on about the grid transition on January 29th at 11:30 a.m. Then there's a session on January 30th, application programming interface. It's they love to throw out these acronyms like API, thinking everybody knows what you're talking about, which almost nobody knows what you're talking about. But essentially, what these are is like an artificial intelligence that's built into these design systems that can then look at the data. It gathers a lot of data about these potential homeowners, such as how much money they're making, how many people live in the house, that kind of thing. And so the salespeople love this because you can then target neighborhoods and houses and drill down. So they're just talking about how you use API information. We're kind of in a drought of these webinars. Oftentimes we get 6 or 7 every day. Well, right now at the beginning of the year there aren't that many. So we got a couple of conferences. February 11th through the 13th is PowerGen in Dallas. And then there's another conference February 25th through the 27th, Intersolar in San Diego. And NABCEP, of course, March 24th through the 27th. This is kind of a good installers conference. They typically sell out. So if you are thinking you want to go to Reno for the NABCEP conference, you might want to sign up early because they do have limited space for conference participants. It's not like a trade show, it's a conference. And you'll need to get in there and get registered early. And then, of course, our certification courses and our online training courses and the like, you can find at solarpvtraining.com. And our textbooks and the like, you can find at the same spot. So that's my shameless plug. And that is all the news, all the news and all of the events that are coming up. So let me jump into the next thing, and maybe hopefully we'll get some discussion going on here with folks. But I'll tell you the background here on what led me to pick this as a topic, because we're doing a small, just a 6 panel. It's a demonstration classroom type solar install, and it's using Enphase microinverters. It's at a classroom for a career training center, which turns out to be a commercial building, of course. So some of the permitting has gotten to be quite annoying, and especially given the very small nature. It's literally 6 panels with 6 microinverters. But 2 of the meters at this location are three-phase 208 volt, and one of the meters is a single phase 240, a single phase split phase, similar to what we do in residential. So our plans were to connect in with the single phase service panel. Turns out that service panel is kind of old, kind of full, and it might be easier to link into the 3-phase. So we began to do some research as to what's involved in that. And that led me to look at some of this stuff to discuss it. So that was sort of some of the background there, because is it practical? Is it practical for us to simply just say, okay, well, let's switch from the single phase connection, let's do a 3-phase connection? Because always in the past, like with the IQ7s, the M250s, the IQ6s, they always said these things are good for 240 single phase or 208 3-phase. And all the spec sheets state that. Well, I'll give you a preview on this. That is no longer the case, much to my chagrin on this particular project. So why focusing on Enphase is they're dominant. They're the dominant player in the residential marketplace. You can see from this chart here from Energy Sage that in 2020, they were a little over 50%. Now they're closer to 70% of the residential inverters that are installed nationwide. It has been a battle between, for instance, SolarEdge and Enphase. But SolarEdge has just lost such a tremendous amount of market share in recent years. You can see that in 2020, they had, about 30% of the market, and now they're down to around 10%, let's guess, from that number. And Tesla is picked up as second place, essentially. And a lot of that stems from the fact that SolarEdge has had a lot of reliability problems. So folks are sort of steering clear of that. The installers are steering clear of it, and moving primarily to Enphase, but also moving to Tesla because they've offered some pretty good deals on their product. So that gives you a little closer up, didn't realize. All right, so let's talk a little bit about the evolution of the products from Enphase, because those of us who do these kind of installs, we may be familiar with it and we've worked with all the different types, but for people who just have a passing knowledge on this or just have installed their own system and nothing else, all of this may be new. So if we look at their product line over the years, the M series of microinverters up there on the top line all looked about the same. Seems to me the first one, I don't know if the very first one was the M190 or 195. That's the first one I was aware of. There might have been one before that, but then it went to the 215s, and then it went to the 250s. So the M250s, the M215s, those were logical in their naming because that basically meant they exported 215 watts of power or 250 watts of power. And the M, I'm assuming, just stood for microinverters, not very complicated naming. Their communication system was the Envoy, and the Envoy, the way it worked is the first outlet that was attached to your service panel, you simply plugged that thing in, and it collected the data from your microinverters over power lines. So you just had to plug that in so that there was no interference from other appliances, and it would harvest the data and you could look at it online. And the N-gauge cabling, the things that connected all the microinverters together in parallel, that was a 4-wire connector. So it had these things export 240 volts AC from directly from the inverters. So there was a line 1, line 2, a neutral, and a ground, just like you would do for a 240 watt or 240 volt outlet in your house if you're wiring your dryer. Then a number of years ago, they came out with the IQ systems. Now, the IQ systems are smart inverters per se. That arose from some rules that came out, California Rule 21, which essentially said if you're going to hook an inverter to the grid, it should be smart enough to adapt to certain grid conditions and massage or change the power profile slightly to clean up the grid a little bit. So many jurisdictions began requiring that these things meet the smart inverter concept, and all inverters are subject to the UL 1741 standard, which says this is how you design and manufacture an inverter. And if you are hooking up to the utility in your internet connect agreement, it'll often say must be UL 1741 certified, and that has anti-islanding issues. I don't want to go too deep into that, but it does all the things that an inverter is supposed to do. Well, then a lot of the utilities started saying, okay, well, we want smart inverters hooked up. Well, they came out with UL 1741 SA. And so then they began requiring it. Well, the IQ system meets those requirements. Now, it had a Envoy, the communication system. I think initially it was in a separate box like this one is, but it very quickly became integrated into their combiner box, which I'll show you a picture of later. And then the cable, the Q cable, it really only has 2 wires in there, line 1 and line 2, just the 2 hots. It does not have a neutral and it does not have a ground, which kind of freaked me out the very first time I saw it. And then they've got some retrofit stuff there. So that gives you a sense of how we've evolved. And right now we're in the IQ8 series of microinverters. So that's their 8th generation of microinverters, and these are the IQ8s. And every time they move from one layer to the next, it gets more complicated, for sure. And often IQ or Enphase has been guilty of not making these products backwardly compatible. So that's problematic as well. So we're dealing with that. So okay, so we've got the combiner box here. Let me just show you what it looks like in the inside. And what this combiner box is, because it's AC, it's alternating current. So everything coming out of your panels is converted to AC right at the panel by the microinverter. It's one inverter gets connected to one panel. So this box now contains the communication system. So you see that circuit board that's up there on the upper right-hand corner. That is the communication system. And the breaker that comes attached to that bus bar that's connected into that is the power for that communication system. So you no longer have to buy a separate device that you plug into an outlet. Now it's built into the system. And then aside from that, it's kind of just a simple 4-breaker, like a bus bar, a service panel type thing. It's 4 double pole breakers. So you can basically hook up 4 different branch circuits into that combiner box. So with the IQ8 series, you can put 13 panels in a circuit, in a branch circuit. So that means this combiner box can handle 4 times 13 or 52 solar panels within that combiner box. If you need more, you're going to have to put in a second combiner box. Now, one of the problems with that is these things communicate wirelessly with with the system. They broadcast off your production, they broadcast off your consumption. They communicate with the smart switch, which we haven't gotten to yet. They can communicate with batteries. All of this is done wirelessly, at least it used to be. And if I have two of them, they start conflicting with each other. So that was an issue. The other thing I want to point out is there's a certain number of consumption meters. You see here this on the bottom left-hand corner, there's a thing called CTs. So when you're filling in or when you're wiring your branch circuits to these double pole breakers, you take the line one, the black wire, and put it through that CT. That's how it measures how much power your array is producing. That's CT is a current transformer. And it's just measuring wirelessly there. It goes around the wire and it's measuring how much you're producing. There's also, you can see you can hook in a battery to this if you want to, and there's a connection point to the switch. And then up there on that circuit breaker is a whole bunch of connections for other communication devices. Especially, there are some CTs that you can get that you can run from that all the way to the lines coming in from your utility. And the nice thing about that is those lines from the utility, whoops, I backed up instead of moving forward, is the nice thing about those is you're measuring now not only what's being produced by the array, and that's being measured by the CT there in the combiner box, but then those other CTs that hook around the power lines coming in from the utility, they measure how much power goes back to the grid and then how much power comes in. So by doing that, you can then get real-time measurements of what the array is producing, how much is being used locally in your home, how much is being exported to the grid, or how much is being imported from the grid. So with those two different sets of CTs, you can measure all of those things. It gives you a very nice picture. Plus the fact that each microinverter has its own communication system, you can also see what is being produced by every panel individually. So that if there's a problem with a panel or a problem with an inverter, it identifies itself very quickly and you know which one is having a problem. So there's a lot of good advantages to that. And that's why microinverters have become the dominant player in the market. So then we see now, as I said, every time we do this, it gets a little more confusing, a little more complicated. So now you see there's no longer just one, like the M250. You could buy an M250. That was kind of it. Now you can buy the IQ8, and that's a 240 volt amps. Well, the measure volt amps is basically, think of it as watts. So 240 watts exporting. It's recommended to be used with 235 to 420 watt panels. And then there's the IQ8 Plus. That's kind of the normal one you would use on a home. That can go up to 290 watts exporting, or volt amps, used with 235 to 440 watt panels. In today's market, it's kind of hard to buy a 400 watt panel or smaller, smaller than 400. The industry has pretty much moved to that. And to Bill's point earlier, you might be able to get some good deals on panels that are smaller than 240, they're smaller than 400 watts. From distributors who might be stuck with them and they're hard for them to sell. Well, these inverters only put out 290 watts anyway. So a 350 watt panel is perfectly fine for this. Then we get into, so the IQ8 is sort of the standard residential inverter. Then we get into an IQ8M. These are bigger, bigger output, 325 watts or 325 volt amps. Then we get into even slightly bigger, the IQ8As, and that's essentially 350 watts. And then the IQ8H, which is 380. So these things just get bigger and bigger and bigger. So this is the IQ8 line. If we look at the spec sheet for this, what I was doing is researching to see if these things worked for 240 or for 208, like they always used to. Well, looking at these spec sheets, that's not so much. Well, in the past, if I looked at the IQ7s, you could see right here in the nominal voltage, it could work either as 240 or 208, and it would recognize it independently. You'd have to use 3-wire cable if you're doing it as 3-phase 208, but the unit itself worked just fine, either using it as 3-phase or using it as single-phase. I don't want to be too technical on this because I know some of you it can be a bit confusing here. But so the IQ8s, when looking at their spec sheet, notice all of these IQ8s, the 8, the 8 plus, the 8M, the 8A, the 8H, those give their range basically as 240. Now they say it's a range between 211 and 264. That's normal. 240 is a nominal number, and everything varies between 211 and 264. That's the bottom operating, the top operating voltage, and we just call it 240. But then the only one that they've got here that operates at 208 is that IQ8H, which is designed solely as a 3-phase unit. So in the IQ8 series, they made a jump. They basically said, okay, no longer are we creating microinverters that will work with either system. If you want a 3-phase, you got to buy a 3-phase inverter. If you want single phase, you buy the single phase inverter. You can buy them in different sizes, but you got to know up front what you're doing, which doesn't help me because I never know up front what I'm doing. So we're backing up. So then these are the 3-phase only inverters that they operate, or the product line. There's the IQ8P and the IQ8H, although in speaking with distributors and also with Enphase itself, nobody seems to have the P. So the IQ8P may be phantomware. I'm not quite sure. It's obviously a bigger version of the other ones. So you can buy the IQ8H. You'd have to buy it. It's designed for commercial systems, and they sell you a commercial gateway. Now, the gateway is always a little bit confusing as a terminology. That's basically just their communication system. So when I was talking to the folks at Enphase and also the distributors saying, okay, you've got this 3-phase inverter. Do I need to buy a 3-phase combiner box? Because coming into the regular combiner box, you can hook into a double pole breaker and line 1, line 2. You can monitor it. It's got communication. It's a really great little package. But obviously, if we're using 3 wires, we can't use double pole breakers. We've got to use 3 pole breakers, one for each of the wires, the line 1, line 2, and line 3. So it would need a different structure. It would need a different box. Well, they don't sell it. In fact, they confused everybody I asked, because I guess I'm the first person to ask. So apparently what you have to do is make your own box. You make your own combiner box. You basically get a load center like that, a 3-phase load center, and you would just bring the strings into that at your 3-pole breakers. You could combine them in here and then just run out from these main lugs there at the top, for example. Well, that takes care of the combining of the branch circuits. That would work all right, but it does not integrate the consumption or the production CTs. All of that has to be done through that gateway, through this product here on the right. And I'm not quite sure where that fits in or how it fits in, but it would be another piece of product there that would have to be integrated after you've combined everything in this service panel. So that's complicated. So how do these things fit together? Well, you can see that with the system now, this is the slightly older system that we're using at the moment. You'd have your solar panels. It would go to a combiner box where it could be handled. The communication could either be Wi-Fi or cellular. They sell little cellular units. Then you might go into your main load panel from there, or you might go into your smart switch. And from the smart switch, you would hook in your batteries, you would hook in a generator, and you would connect to the meter. And so that smart switch does all of the things where when the grid goes down, you disconnect from the grid. Now we're going to operate from our batteries, we're going to operate from our generator, or the generator is going to recharge our batteries, or however you've set it up to do. That's kind of it. Now, as I mentioned, this was all handled wirelessly, and that caused some interference between the different products. It didn't even have to be in your home. If your neighbor has an Enphase system, your system might be trying to communicate with their system. So they moved in the last generation here to a wired communication system. You're connecting using basically an RJ45, a telephone type jack, connecting these things together. Well, that's all good. That's all good. I mean, it avoids that problem of interference, but it makes those systems not backwardly compatible now. That's annoying. It's problematic. It's certainly understandable why they did it, but it's still annoying that these products are not backwardly compatible. So then where we are in this world is these are the product lines that we're dealing with. We've got the combiner boxes. And if you're going to look at buying one of these in today's market, if you're using all the latest stuff, be sure you get the combiner 5. Now, another thing that's annoying is these numbers do not match up with each other. So you're going to use a combiner 5 or a 5C. And I would recommend buying the 5C because it has a cell modem built into it. You may not think you need a cell modem, but apparently Enphase feels like you do. So when you go to install it, it's not going to install properly. You're going to have to jump through all sorts of hoops, which you probably won't be given permission to even commission the system until you got that cellular modem hooked in. So buy the 5C. It's cheaper. It adds a little bit of cost, but it's cheaper than buying the cell modem later. And the cell modem comes with a 5-year plan. So when you do install this, you've got 5 years of cellular service for this unit. And apparently they've got 2 different types. You can get one with T-Mobile and one with AT&T. So you might want to double check to make sure what service is available wherever you're installing these. And then you can get into the controller, and this is the system controller 3. This is the smart switch. So remember, it's the combiner 5 hooks up to the controller 3. Now, why didn't they come up with names that were compatible? And then they've got like a controller 3, but then you've got a 3G. So you need the 3G if you're going to have a generator. So make sure you understand that. If you want a backup generator built into this, you need to get the controller 3G. And if you want a cellular modem in your system, make sure you get the combiner 5C for communication, I guess, or cell. And then, of course, there's the batteries. The batteries are IQ batteries 5Ps. They're 5 kilowatt hours of capacity. They replaced the older versions, which were 3T, I think it was. It was a different letter. Anyway, that was a 3 kW system. And you could buy a 10 kW system, but it was just 3 batteries stuck in a box. So now the 5Ps are required if you're using the controller 3, the smart switch 3, because all of these are hardwired together. You can't use the 3 kW version with the new switches and the new combiner boxes. So if you've got the older battery. So just kind of pointing out that it's kind of a mess, kind of complicated. You can do it like Bill does at his installations, is just don't put in any communication systems at all. And then you could just run from your inverter to a disconnect to the service panel. A lot better, but you can't monitor your systems. You can't use all the bells and whistles. I guess you can monitor them by looking and seeing if the little light is flashing green or if it's flashing red, but it's kind of the only way of doing it without all of these bells and whistles. And then I just wanted to add the last piece of equipment that goes in here is what they refer to as an RSD. It's a rapid shutdown disconnect. It's basically the way you turn off the battery bank, and it hooks into your smart switch. And it's just a switch that's out there. I can give you a close up, but that may not tell you anything. And it's got in here, you hook into this little port in the smart switch, and then you go outside and you put this switch out there next to the disconnects of your system. The reason you need to have that is, you've got a disconnect from your solar array. Well, when they come and turn that off, your solar array, of course, is supposed to shut down up at the panels. Well, the microinverter shuts off right then, right? Up at the panel. It's clamped into the panel. So that's good. That's referred to as rapid shutdown. Well, what happens when we pull the solar, when we turn off the utility, which is sort of the second thing that a firefighter or a first responder might do if your house is on fire? Well, your system's smart enough to then recognize there's no grid, so it goes into backup and it turns on the battery system. So you still have power in the house, even though they've turned off the solar array and they've turned off your grid, because you're now operating off stored battery. So there's got to be a switch out there where you can turn off the battery as well. Because when the firefighter responds, he wants there to be no power in the house so he can cut through your roof with a chainsaw and not risk getting electrocuted. So that's why at this point, when you've got that system, you're actually going to have sort of 3 disconnects right out there by your meter. One to shut down your system, one to disconnect from the array or from the utility, and the other one to turn off your backup battery. Okay, so that was a lot to cover there in a fairly short period of time. We got a couple of minutes. Did anybody have any questions before we call it a day here? Give you just a second. Hopefully that was helpful. And everybody's being very quiet. So yeah, go ahead.
I had a question about the limit, the 13 panel limit on a branch for Enphase.
Yeah.
If, I'm not sure why they originally came out with the M series, why they came out with prime numbers that should be divided on separate legs on a branch. I mean, why would you have 17 and how do you divide it between 17? And now if it's 13, obviously the voltage doesn't cascade high enough to get outside the window if there are 7 inverters in a branch. So why not go to 14 panels in a branch? Because technically they will still all operate within the voltage window of the inverters.
Yeah.
And why couldn't you just put a bigger breaker on the other end, a 30 amp breaker instead of a 20 amp?
Yeah, the purpose for that is, and it's easy to get it confused, but if you're used to working with string inverters, when you hook them up in a string, the voltage increases, but the amps remain the same. Yeah. So you can go up to whatever the limitation of voltage of the NEC for the building. But with these, you're making a parallel connection. So every time you hook up one inverter to the next, the voltage is always going to remain the same. It's always going to be 240 volt AC if it's a single phase system. But every inverter adds a certain number of amps to the system, a certain amount of current. Well, it turns out if you were to take like 290 watts, which is what this IQ8 Plus produces, divide it by 240 volts, you get, I believe it's like 1.2 amps. Well, the NEC requires a 125%, fudge factor. So you multiply that times the 1.2 amps and you get 1.5 amps. So it just sort of turns out the cable they decided to use in their proprietary cable only has the capacity of 20 amps. So you divide 20 by 1.5, you get a maximum of 13. These things don't have to be balanced, right? I could put 2 strings there, or they're not technically strings. They're branch circuits because they're not in series. I could put 2 of them there. One could be 13 and one could be 6. They don't have to balance like you have to with a string inverter system. So that part with the prime number thing doesn't become a problem. The way they could expand the number that could be in a branch circuit is they could just put bigger wire. in these proprietary cables. They've chosen not to yet, but my guess is with some of these bigger microinverters, they're going to have to. Otherwise, they're only going to have 6 or 7 in a branch circuit. So we'll probably see them moving to 10 gauge wire, something like that with a 30 amp capacity as opposed to a 20 amp. But it's all limited by the proprietary wire that these things are making a parallel connection to. Did that sort of make sense to you, Bill? You're still muted there, so I'll assume it made sense.
On one of the legs of the branch, it's going to be 7, and that's adequate for it's the wire in the cable is adequate for 7 on one
Right.
leg of the branch. So why not for both legs of the branch
You
at two
could.
7 panels, 7 panel legs?
You could, but remember, the amps can be combined in any amount. You just have to go to a bigger wire. So I could have 2 7. It's just saying the maximum on that proprietary wire is 13. But you can put
Okay.
5, you can put 7, you can put 10. Doesn't matter. And they don't have to balance. If I've got multiple branch circuits coming in, they don't all have to be the same. I could have a 13, I could have a 5, I could have a 6, whatever it is. The amps will just accumulate because they're all coming in at 240 volts AC.
Okay, so in the junction box or in the combiner box, it would be fine as long as you run an 8 or a 10 gauge wire going out of the box.
Yes. Yeah, whatever the external, because that combiner box has the capacity of handling 80 amps. So I always recommend you put wire big enough to handle 80 amps coming out of it, when you're installing it, because you don't know what you might add to the system,
Sure.
in the future.
Thanks, Jay.
Okay. All right. Well, we're going to call it a day. We're right up against it. So I appreciate everybody's attention, and we'll see you guys all next week. Take care.